So IR table. So this is one of the handouts you always will get. Kind of the way I think about it, I really don't worry about this fingerprint region too much. When I'm analyzing an IR, I kind of like to work from left to right. So I worry about NHs and OHs, which are going to be broad, right? Big and broad, right? They will not be sharp. And then I look at the CHs, and there are all different types of CHs. There's SPCHs, SP2CHs, SP3, or alkene, alkyne, alkane. There's a triple bond region, then the double bond region. See a lot of carbonyl types around here too. So let's see. So let's go dive into specifics, especially for the CHs as well. Okay. So let's look at the specific kind of numbers here. What you'll see is the OHs and NHs, right? I really don't worry about this one too much. I worry about these strong, moderate, broad, right? These are going to be broad peaks, right? They're going to look a lot like this kind of thing, or maybe like that, like very like kind of fat, I guess I'd say. And then from there, I start looking at my alkane, alkene, alkyne kind of stretches. Right? So alkane is just another way of saying, right, sp3, alkene is sp2, and aromatic is really a certain type of sp2, right, like the benzene ring, but it's still sp2. And then alkyne is sp, and then we know aldehyde, right, is that. So all these are good things to take a look at, right? So alkanes are always below 3,000, right? If you see something that's sharp above 3,000, that means you have sp2 CHs, right? That's usually a good clue to tell the difference between these. But if it's below 3,000, it's sp3. If it's above 3,000, it's sp2, or a benzene ring. And these alkyne ones are really strong and narrow, so you really see these ones are like really sharp, but they're at like 3,300, right? That's that SPCH, right? So you really see that terminal alkyne CH there. So that's a good place to kind of like look and see what I have, to see what's around there, right? And these wavy lines mean approximately, right? These never like perfect numbers. Then I look at the triple bond region, look for alkynes and nitriles. Again, you can tell the difference between an internal alkyne and a terminal, because a terminal one has a CH, would have something like this. Nitriles and internal alkynes don't. And then, I mean, it depends on what I'm looking for, right? So if I'm just given an IR and I'm trying to figure out which molecule it could be, I look to see if it has a C-double bond. If I'm already given the molecule, right? If you're like given, okay, it's this structure, what IR stretches are, then you can look at the specifics and label them out if you want to, what you predict they would be at. But if you're not given the specific, if you're just trying to eliminate possibilities, don't try to be too specific. But if you're given the specific molecule, then you can be specific, if that makes sense. Then after that, I don't worry too much going on after that.